Type 1. Stellar black holes, the most common type, and the most violent origin story in the universe. Most stars spend their entire lives in a standoff, gravity trying to crush inward, nuclear fusion pushing outward. As long as there's fuel, it's a stalemate. Every star runs out of fuel eventually. For a star more than 8 times the mass of our Sun, there's no gentle death. The fusion stops. Gravity wins. The core collapses in less than a second. The outer layers, millions of kilometers of star, come crashing inward and then explode outward in a supernova. What's left at the center is a stellar black hole, between 5 and 100 times the mass of our Sun, compressed into an object roughly the size of a city. Picture Lower Manhattan. Now fill it with the mass of 20 suns. That's the density. We can't see them directly, they emit no light, but we can see what they do to everything around them. Gas from nearby stars gets pulled in, forms a spinning disk, heats up to millions of degrees, and glows in X-rays loud enough to detect from Earth. That's how we found Cygnus X-1, one of the first confirmed black holes. About 21 times the mass of our Sun, locked in orbit with a blue supergiant star. Stephen Hawking once bet it would turn out not to be a black hole. He lost. There are probably millions of stellar black holes in the Milky Way alone. Most are dormant, dark, drifting. We only notice them when they feed. Type 2. Intermediate black holes. This one is the missing link, and for a long time, nobody could find it. Between stellar black holes, a few dozen solar masses, and the next type, which is millions of solar masses, there's a gap. Something should be living in it. Intermediate black holes. Hundreds to hundreds of thousands of solar masses. Here's why they matter. We know stellar black holes exist. We know supermassive black holes exist. But how do you get from one to the other? A stellar black hole can't eat its way up to 1 billion solar masses in time. The math doesn't work. Something has to bridge them. In 2024, astronomers found the strongest evidence yet, hiding inside Omega Centauri, a massive star cluster orbiting our galaxy. Stars near the center were moving too fast. Something invisible was pulling them. Around 8,200 solar masses worth of something. Not confirmed, but the best candidate we've ever found. The missing link might finally be pinned down. Type 3. Supermassive black holes. These are the monsters, and they don't live at the edge of galaxies. They live at the center. Almost every large galaxy in the observable universe has one, including ours. Sagittarius A star, 4 million times the mass of our Sun, sitting 26,000 light-years from where you're standing right now. In 2022, the Event Horizon Telescope produced the first direct image of it. 8 telescopes on 5 continents, synchronized to work as one Earth-sized telescope. The result? A glowing orange ring, the shadow of a black hole, cast against its own accretion disk. M87 star is another one, 6.5 billion solar masses. In 2019, it became the first black hole ever photographed. Some supermassive black holes are actively feeding. We call those quasars. The brightest object in the observable universe right now is a quasar, J0529-4351, powered by a black hole eating the equivalent of one sun every single day. It outshines its entire galaxy by 1 trillion times. 1 trillion. Type 4. Ultramassive black holes. Supermassive isn't even the limit. At the extreme end sit ultramassive black holes, anything above 10 billion solar masses. TON 618 is the most famous, 66 billion solar masses. Its event horizon spans 13 times the diameter of Neptune's orbit. Place it at the center of our solar system and it swallows every planet, every moon, and extends out past Neptune. These objects sit at the centers of the largest galaxies in the universe. Galaxies that formed through billions of years of mergers. Galaxy eating galaxy, black hole merging with black hole. When two supermassive black holes collide, the gravitational waves released are among the most powerful events in the universe since the Big Bang. In 2015, LIGO detected gravitational waves for the first time. 2 stellar black holes merging 1.3 billion light-years away. The entire Earth moved by less than the width of a proton, and we noticed.